Srpski tako dobro i onda ja ću pričati na engleskom, pošto sam čuo da je ovo svjetski konferencija. I isto za moje kolege koji ne pričaju srpski, engleski. So thank you to the organizers of this wonderful conference, and I'm going to talk about Nikola Tesla's important contributions to modern physics. So I just wanted to, I'm excited as a scientist that we have many examples where Nikola Tesla has become very popular in the past 10 or 20 years. He was even in a film, The Prestige. He's been on a couple of United States stamps. And of course, there's the car manufacturer Tesla and a rock group as well that was named after him. And of course, as a child, I remember my father bought many stamps of this the centennial anniversary for Nikola Tesla, 1956. So, as a Serbian-American genius, and I always loved that stamp on the bottom, right there. Oh, and so how I really got interested, first of all, my ancestry is from Serbia, and my mother, her last name was Smiljanic, and her parents were born in Lika, which was, in Tesla's time, it was Austro-Hungary. Today it's Croatia. And so I actually visited there in 1988, and I took this photo was at the Tesla Museum in Smiljan, and my mother's last name was Smiljanic, so it means her ancestors came from Smiljan, so I feel a small connection, even if not genetic, is certainly a small connection to Tesla. So I just want to emphasize just a few points, given the limited time that I have, that I'm going to focus on. There are many, I could talk for hours, as we've seen in earlier talks, I could go on and on about Tesla, but I just want to focus on 3 to 4 main points. The first point is that Tesla taught us how to generate high voltage and high frequency. Okay, when you look at, I can't find anything preceding his Tesla coil in terms of a safe way to generate high voltages and very high frequencies into the kilohertz and beyond. He also taught us about natural resonance, the concept that if you push a child on a swing and you push at the right frequency, you will add to the motion, you will contribute to the amplitude. And to Tesla, that was essentially, that was a lot of how his viewpoint of nature. And so he also taught us how to harness tunes via the tuned circuit, electrical and magnetic fields to stimulate and detect resonance. And then he also taught us how to transmit energy wirelessly. Yes, Heinrich Hertz did some of the first experiments where he proved that, in fact, this by accelerating charges, he would transmit electromagnetic radiation, but it was Tesla that, in fact, used that for practical benefit. So, just to give you, again, a small perspective, I could go on and on, but I'm going to focus on just a few of the areas of physics that he really contributed to. Nuclear magnetic resonance, or magnetic resonance imaging. Everybody knows about that. That's how we detect molecules. For example, organic chemists, when they synthesize chemicals, they will use NMR to detect, to see what they made, if they made them properly. But of course, it became very important because of the concept of MRI in hospitals. People can non-invasively investigate your body to see if you have a tumor or blood flow if your brain is thinking using MRI. Electron spin resonance was actually first discovered by the Russians. Zavodsky, for example, was really the one who discovered that, and that was the precursor to NMR. High energy physics, particle physics, accelerator physics actually had roots with Nikola Tesla. And then Nikola Tesla's work with lightning and radio transmission, that's where atmospheric physics has tremendous a debt to Tesla. And then radar, LiDAR, laser optical methods related to Tesla, plasma physics, and then of course the medical physics in part with the MRI. So the first thing I want to focus on is that the Tesla coil was really the first successful effort to produce high frequency, high voltage. And so he taught us how to generate this. Here you can see in this picture on the left, he is sitting very comfortably, very peacefully, and he's not being bothered by the currents, in part because any currents that go through him would go through his skin, the skin effect. And so he was one of the first people to realize that, and basically to show how safe this could be. So the Tesla coil he was looking to approximate the frequency of sunlight. That means visible light. Remember, when he was operating, when he was working, doing his experiments, this is the 19th century. So most of the quantum mechanics was just, maybe starting late 1800s, 1880s, 1890s, Planck. And so people were really confused about what sunlight was. They didn't even really understand until they understood fusion. Max Born, for example, where, what was the source of the energy in the sun. So this is where he developed this Tesla coil, and it's essentially a very high voltage transformer, but it has a spark gap. And so with that spark gap, he was able to generate very high frequencies and enormous voltages. And of course, with the enormous voltages, now you could start ionizing molecules, atoms in gases very easily. And this was sort of the precursor to the phosphorescent bulb, and then of course the fluorescent lighting, which I consider him the father of, essentially. And then once he realized, the Tesla coil is always a dramatic thing. I demonstrated a lot in my classes. And you can, when you see that you can turn on a light bulb, by just holding it some distance away, you'll realize that this is how he began to become obsessed with the wireless transmission of energy. So again, just as I said, the Tesla coil is just basically you have a secondary, primary coil that it jumps up the voltage to very high voltage up here, and then electrons become very high voltage, so high potential, so they want to go to, lower potential actually because they're negative, and then they want to go to high ground. And then you have a spark gap here, and you can tune that spark gap, and it's very dramatic. Most people don't realize that a spark plug, which is found in every car or combustion vehicle, is in fact is a Tesla coil. Is similar to a Tesla coil. So Tesla had one of the first patents out for a spark plug. Nobody knows. People think Bosch invented it, but in fact it was really a Tesla coil, and that's how you can generate sparks to ignite a mixture. I just want a brief comment about X-rays because I do research with X-rays. Anytime you get above 1,000 volts and you accelerate charges like electrons, you're getting into the range of X-rays. So Tesla was one of the first people to generate extremely high voltages, kilovolts, tens of kilovolts with his Tesla coil. And so as a consequence, in my opinion, he probably was one of the first generators of X-rays. Did he understand what he was doing? Probably not. He did he was friends with Röntgen, and they did collaborate. Tesla obviously did not get any credit for the discovery of X-rays, but he probably did take the first X-ray picture here. And again, as a physicist, he was the first one really to conquer high voltage. Once you conquer high voltage, then it's very easy to have spark discharge where, with the Bremsstrahlung effect, essentially you produce X-rays. All right, so now high energy physics. Tesla was one of the first, and I call him a physicist, by the way, because he did do graduate studies in physics, and he was a combination of a physics and an applied physicist or an engineer. And so he was basically, because everything, in science, when we use science, we understand a little bit, then we develop new technology. Then with that new technology, we can do experiments and understand more about the natural world. So this was this sort of symbiosis with Tesla, and that's why I call him a physicist. He was one of the first to grasp the distinction between lumped and distributed resonance. So this is where we look at cavities. We're looking at cavity resonances. And so after conferring with Heinrich Hertz in 1882, he was the first to patent voltage magnification via standing waves on distributed resonators. I love to hear that as a physicist because I know how important that is as I work with accelerators in my research. And so this technique would be later used by David Sloan, Ernest Lawrence, and Louis Alvarez in the development of modern particle accelerators. So here's an example of the LEP-L3 detector, which I was involved in in a project when I was an undergraduate at Caltech, and some of the beautiful physics would just not be possible without having that ability to not only generate high voltages via something like the Tesla coil, but also to essentially develop these standing wave oscillating cavities that will push along particles, and each time they go around, either to stabilize them or to actually increase their energy. So I like this paper because this was a very fundamental one, radio frequency high voltage generated by Sloan. And you can see in the abstract, here he mentions Tesla coils. So now he improved on those Tesla coils, that's fine, but the point is, here at least he recognized that this was sort of the foundation of generating this ability, this technique of accelerating particles. So to generate astonishingly high voltages and high frequencies. And so this paper improved on Tesla's high voltage techniques. And modern day accelerators, for example, there's the radio frequency quadrupole, RFQ accelerator, which Argonne National Laboratory at the Advanced Photon Source that I work at due to experiments, utilizes Tesla's ideas of distributed cavity resonance. I do realize Tesla's ideas were more 19th century, but nobody really talks about his contributions that made today's physics possible. And so there's a paper that discusses this, and these are just, again, I'm not getting too technical here, but just to show you the idea of oscillating magnetic and electric fields that essentially propels, if they're in the right speed, it's sort of a sequence like being on a carnival ride. It'll keep pushing you forward, and you can pick up energy. So I do a lot of my experiments at the Advanced Photon Source in Chicago, Illinois. This is about 2 kilometers in circumference. Each of these little triangles represents a beam station, a beam line. And so we, at UNLV, we own 20% of the Sector 16. So this IDB is one of the 5 beam stations at Sector 16, and it's the most productive beam line at the Advanced Photon Source. And so here at this pipe here, this is where X-rays come, and then we put our sample in between on a stage right here. Then we have an X-ray detector. And again, my point is simply that we have a lot that we owe Tesla because of the ability to easily generate X-rays, astonishingly high fluxes of 10 to the 12 photons per second. And that's how we can do experiments in the diamond anvil cell, which is my area of expertise. And I've actually developed a new field of science, useful hard X-ray photochemistry, and I have a lot that I feel I owe Dr. Tesla, not only for what he did to make synchrotrons possible, but also because of his discoveries of X-rays. And again, I do believe he was one of the first people to observe X-rays. And so we can make beautiful science irradiating through a diamond. You see, seeing through a diamond sample, for example, of potassium chlorate, here releasing oxygen. Oxygen changes color in the solid state with pressure. And we can actually release all sorts of new molecular oxygen, fluorine, chlorine, nitrogen, and hydrogen. And we're hoping that this will have a lot of new science, not only for materials under extreme conditions, which is my field of research, but also maybe for hydrogen, the hydrogen fuel cell, and even possibly a novel doping technique. Now, the next thing I want to focus on is Tesla's tuned circuit, okay? I remember reviewing a college physics textbook by Nicholas Giordano, and he mentions the alternating current. Of course, he didn't mention Tesla, and then he goes on to talk about the radio. And I'm reviewing this book, and he mentions Marconi. So I write him, and I sent him this patent. I says, as a physicist, everything about the radio, the essence of the radio is this simple concept that is Tesla's. Look at the Tesla name up above. The concept of the transmitter and the receiver. The transmitter broadcasts at a fixed frequency. The receiver is set to that frequency, so it can only pick up that. So it's a tuned oscillator. And why is that so critical? Tesla understood, for crying out loud, in the 19th century, he understood that if this became so popular, people would be talking in all sorts of different frequencies, and nobody would understand each other. So the whole essence of radio is that this essence of the tuned circuitry that came from Tesla. It's right here. Okay, he was the first to patent this. And of course, that's the basis of all of modern communications. Your cell phone, television, radio starts with this. To me, as a physicist, everything else, and I don't mean to put down Marconi or any of the other greats who developed this, but it's really trivial. I mean, this is the bedrock of modern communication. Okay? Now,
so what did he say?
Who said? Tesla?
No. What, this guy, when you...
Well, Marconi, Tesla, when people asked him about Marconi, he said, go ahead, let him have precedence, but the point is he's using something like 18 of my patents. That's a fact. I mean, the U.S. Supreme Court decided that in 1943. So the point I wanted to also make is that this is also, that most people aren't aware of, this is the essence of nuclear magnetic resonance and electron spin resonance. Instead of a person talking in the transmitter, it's quantum spins. It's protons in the case of nuclear magnetic resonance, or fluorine nuclei, or carbon 14 in the case, or 13. In the case of electron spin resonance, the electrons are talking. And then we build up a circuit to detect essentially the resonance, what we call the nuclear magnetic resonance. So the spins, as they spin in a coil, they induce a voltage, and the voltage is detected by a receiver coil, and then that's the essence, the bedrock of NMR. Well, that's Tesla. Okay, now, NMR was developed in 1946. This was going on the late 1890s. So some 50 years had passed, so one might say, well, okay, maybe that's why they didn't really think about it, but I want all of us to think about that in terms of being appreciative that Tesla was really the founder, the beginner of this idea. So I did my PhD thesis on NMR and high pressure, and I have the world's records, no big deal for studying anything at high pressure with NMR. And here are two diamonds. They squeeze on a sample in a gasket. This has got a special insulating material to make a one-loop inductor. That's how the currents flow, and then we have a capacitor. This is all based on Tesla's tuned circuitry. And I succeeded. I managed at 223 megahertz to measure NMR of hydrogen at very high pressures, and then we couple this with the coax and it goes outside. And again, so I have much to be in debt to Dr. Tesla, because again, when I see that, I see Tesla's original ideas for radio. So again, the essence of NMR is tuned circuitry. Here's an example of a sample. You have a coil. That's your pickup coil. Now, in the case of Fourier transform pulsed NMR, the coil serves as both the transmitter and the receiver. In the presence of an external magnetic field, that causes the spins to precess. And then you can see here, in the same language as Tesla would have said, radio frequency receiver and amplifier, and the little sweep generator, that's just some details. But that's the essence. And then here, Tesla, radio frequency transmitter. That's the essence of NMR, and that's Tesla. And then, of course, in today's MRIs, when people go for an MRI scan, the same idea. You have this big external magnetic field that causes the spins to precess, just like a top precesses in the presence of the gravitational field. And then there's a coil, a pickup coil, that couples, that basically asks your protons, which are mostly the water in your body, to talk to that coil, to couple, and then that's how you can get an MRI of a patient. I did a lot of NMR when I was an undergraduate, and I actually discovered an effect, the Altadine effect. Here's a beautiful picture. When I remember first seeing it, I'll never forget, of the fame and predict these natural frequencies. These are the natural frequencies here of protons in ethylbenzene. Much of modern physics is based on this principle, and that's the first time I've seen it, is that idea of the tuned resonance. Then, of course, I want you to look at this picture. This picture came up many times during the talks, and it's a beautiful picture. Now, of course, you might be comfortable saying, yeah, that's an antenna. That's something we see ubiquitous. It's all over the place, all over the world. But I want you to realize that, look at the date, 1899 to 1900. Now, think about that. Do you think that many people had antennas or even understood the concept of antenna at that time? Not as far as I can tell. I can't find any earlier photographs Possibly Heinrich Hertz, he might have, but I couldn't find anything like this during that date. Okay, so the whole essence of Tesla is to this is his wireless transmission. Okay, was development of an antenna, but you see he was so far ahead, people had to kind of catch up, and that's why nobody really talks about that. I don't know if he was the first to invent the antenna, but I will say this, that Tesla also proposed transmitting extremely low frequency waves into the cavity that exists between the surface of the Earth and the ionosphere. So he was one of the first people to work with the ionosphere, which is a kind of a charged, almost a plasma just coming from all the ionization from the sun's radiation in outer space. So he used that to bounce off and again, had he not been beaten by Marconi, he would have easily used this to send the first signals across the Atlantic. So this is known as the Schumann cavity. Now listen to this, named after Winfried Ottoman Schumann, who rediscovered this region in 1952. In the 1990s, this was renamed, and I'm glad they did, because they sure owed it to him, the Tesla-Schumann cavity. Tesla even proposed transmitting power into the ionosphere itself. Instead of, remember we had talks about inside the Earth's crust, now he wants to transmit into the ionosphere, and because I agree with him, it would be very highly conductive. And this proved true in experiments heating portions of the ionosphere are used today. And again, I'm not going to get into that, but there are some arguments that people have been doing experiments, I don't know successfully or not, trying to alter the weather by coupling energy into and out of the ionosphere. Okay? Another thing that I don't hear much about is the phosphorescent lighting, which was the precursor to fluorescent lighting, was in my opinion, one of the first successful efforts to produce a contained plasma. Plasma physics is a big deal for those of you who may know about fusion, nuclear fusion, and Tesla showed us, again, with his Tesla coil, how we can generate high voltage, high energy discharge. Once you have high energy discharge, you can easily produce a plasma. And so, again, I look at Tesla as essentially the father of fluorescent lighting. Yes, were there improvements made on his inventions? Of course. But I can't go back further. When I'm looking at when people were doing this, people had the Giesler tubes, but this was a serious effort to make a very powerful plasma, and not enough supporters. Why he would not have shared the Nobel Prize with Marconi, because that's where it begins. That's really the next generation. And it just saddens me, because this happens in any field of human endeavor. There's what we call politics. And as we know, Tesla did not make friends in the corporate world, because Tesla was about free energy and freeing the humans, and they were about control. And I mean, that's well documented. So the thing is, the sad thing is just that, Tesla Tesla showed us, he gave us hope as human beings, that one person can change the course of humanity, can change the future. And that's what I want people to take that's the take-home message. Tesla's in a better place, in my opinion, so he's got the rewards that he needs. But for us, he gives us hope, okay? That one person can do a lot, and there's no reason to give up and just keep trying. And I admire him, because I think, I'm an American, I was born in the United States, but I have trouble as a scientist. I have a patent, we've applied for patents. It's tough navigating the politics and getting support. Now imagine what it would have been for an immigrant who didn't speak English probably perfectly, with an accent, and how would they have seen him in those days, in the 1880s? And so that I think about that. I think about what my grandparents went through. And then I begin to, I believe, become a little closer into understanding why, how he struggled. But despite that he could do all this, whoa, that was amazing.